Hi, how are you doing? This is Analysis by Doing. I'm Manu Vasudevan, Data Analyst and Certified AWS Solutions Architect at your service. Welcome to Analysis by Doing, a series of data analysis sessions in which we do hands-on projects analyzing data using Amazon Web Services. The target audience is aspiring data analysts and AWS Cloud enthusiasts. What good is any knowledge when not put to good use? We will exercise our AWS skills on the terrain of data science. Join us in our data analytics journey in the vehicle of Amazon Web Services. Welcome to this session on Pandas Overview. We will review our portfolio website before the Pandas Overview project. We will perform an overview of the following: Pandas object creation, reading in a data file into a DataFrame, viewing, selecting, and setting data, miscellaneous data operations, saving and loading Pandas objects, and plotting data. Then we will update index.html to publish our Pandas Overview project. Next, we will upload the new Pandas Overview project file to the S3 portfolio bucket. We will then review our updated portfolio website after the Pandas Overview project. Next, we will stop but not terminate the Analysis EC2 instance. Finally, we will perform best practices, review billing dashboard, and our budget alarm. To keep us motivated to produce more of such high-quality free content, please subscribe to this channel, hit the like button below, leave a comment or two, and share this video with your colleagues, friends, and other budding cloud analysts. Hit the bell icon below to actively follow along with the rest of our series. We now understand Pandas object creation and reading in a data file into a DataFrame. Let's understand viewing, selecting, and setting data. View the top rows of the DataFrame. Key in the code irisdf.head, open and close parentheses, then hit Alt and Enter. Note that the head function, by default, shows the first 5 rows. View the bottom rows of the DataFrame. Key in the code irisdf.tail within parentheses 3. Then hit Alt and Enter. Note that the head and tail functions can be made to show a specific number of rows. Display the row index. Key in the code irisdf.index, then hit Alt and Enter. Display the column names. Key in the code irisdf.columns, then hit Alt and Enter. Get a NumPy representation of the data inside the DataFrame. Key in the code irisdf.to_numpy, open and close parentheses, then hit Alt and Enter. Scroll down to the bottom and note that the two-dimensional array is of D-type object. Create a duplicate DataFrame object by making a deep copy. Key in the code floatsdf equals irisdf.copy within parentheses deep equals true, floatsdf. Then hit Alt and Enter. Note that the newly created DataFrame is a distinct object. Drop the only column with string data from the new DataFrame. Key in the code del floatsdf within brackets within quotes plant class floatsdf. Then hit Alt and Enter. Note that the DataFrame floatsdf has only numerical data. Get a NumPy representation of the data inside this DataFrame. Key in the code floatsdf.to_numpy, open and close parentheses, then hit Alt and Enter. Scroll down to the bottom and note that the two-dimensional array is not of D-type object. Also, note that the row index and column names of the DataFrame are not included in the NumPy array. Transpose the data in the DataFrame. Key in the code floatsdf.t, then hit Alt and Enter. Note that the columns of the previous output have become rows and vice versa. Get a quick statistic summary of the iris DataFrame. Key in the code irisdf.describe, open and close parentheses. Then hit Alt and Enter. Sort the DataFrame by values in a specific column. Key in the code irisdf.sort_values within parentheses by equals within quotes sepal length. Then hit Alt and Enter. Note that the original row index number is retained. Furthermore, only above output was sorted. Key in the code irisdf, then hit Alt and Enter. The original data frame is not modified. Sort the actual data frame in place and modify the row index also accordingly. Key in the code irisdf.sort_values within parentheses by equals within quotes sepal length comma in place equals true comma ignore underscore index equals true. Then hit Alt and Enter. Note that nothing is output but the sorting and reindexing happens internally. Check out the modified data frame. Key in the code irisdf. Then hit Alt and Enter. Beware, the above internal sort operation cannot be undone. Sort the column headers in descending order by an axis. Key in the code irisdf.sort_index within parentheses axis equals 1 comma ascending equals false. Then hit Alt and Enter. When axis is 1, it scans from left to right. Check the contents of the downloaded data file data/auto-mpg.data thanks to UC Irvine Machine Learning Repository. Key in the code !type data \auto-mpg.data. Then hit Alt and Enter. Note that there are no column headers in the space delimited file auto-mpg.data. Read the document auto-mpg.names associated with the data file auto-mpg.data. Key in the code !type data \auto-mpg.names. Then hit Alt and Enter. Note the attribute information section, which specifies the column names of the dataset. Also, note that the 9th attribute, car name, is supposedly unique for each row of data. However, FYI, the car name Chevrolet Chevelle Malibu is repeated in the dataset. Compose a list of column names for our autos dataset. Key in the code call_headers equals a list of strings mpg, comma cylinders, comma displacement, comma horsepower, comma weight, comma acceleration, comma model year, comma origin, comma car name. Call_headers, then hit Alt and Enter. Read the space delimited file into a Pandas data frame specifying column names and the index column. Key in the code AutoDF equals pd.read_table within parentheses data/auto-mpg.data, comma delim_whitespace equals true, comma header equals none, comma names equals call_headers, comma index_call equals within quotes car name. AutoDF, then hit Alt and Enter. The loaded data frame has the specified column names and the unique car names column is the row index. Display the row index. Key in the code AutoDF.index, then hit Alt and Enter. Display the column names. Key in the code AutoDF.columns, then hit Alt and Enter. Get a quick statistic summary of the data. Key in the code AutoDF.describe, open and close parentheses, then hit Alt and Enter. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in two hashtags selection, then hit Alt and Enter. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in three hashtags getting, then hit Alt and Enter. Get a single column from a data frame. Key in the code AutoDF within brackets, within quotes, horsepower. Then hit Alt and Enter. It yields a series object. Another way of selecting a column in a data frame is by using the dot notation. Key in the code AutoDF.horsepower. Then hit Alt and Enter. Get specific range of rows from the data frame with brackets. Key in the code AutoDF within brackets 0:3. Then hit Alt and Enter. This is also called slicing with rows. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in three hashtags selection by label. Then hit Alt and Enter. Get a specific row using a row label. Key in the code AutoDF.lock within brackets, within quotes, Buick Skylark 320. Then hit Alt and Enter. Select on a multi-axis by comma-separated row and column label. Key in the code AutoDF.lock within brackets, colon, comma, list of strings, mpg, comma, weight. Then hit Alt and Enter. Get DataFrame rows by label slicing. Key in the code autodf.lock within brackets vw pickup colon forward ranger comma list of columns mpg comma weight. Then hit Alt and Enter. Note that both lock endpoints are included. Get a scalar value, the intersection of a row and a column. Key in the code autodf.lock within brackets forward ranger comma weight. Then hit Alt and Enter. A faster way to get the same intersection of row index forward ranger and column weight. Key in the code autodf.at within brackets forward ranger comma weight. Then hit Alt and Enter. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in 3 hashtags selection by position. Then press Alt and Enter. Select the row in the third position, counting from 0. Key in the code autodf.ilock within brackets 3. Then hit Alt and Enter. Select by integer slices of third to fifth row excluded and 0 to second column excluded. Key in the code autodf.ilock within brackets 3:5, 0:2. Then hit Alt and Enter. Select rows in position 1, 2, 4 and columns in position 0 and 2. Key in the code autodf.ilock list within a list 1, 2, 4, 0, 2. Then hit Alt and Enter. Select from first row to third row excluded and all columns. Key in the code autodf.ilock within brackets 1:3, colon. Then hit Alt and Enter. Select all rows in column positions 1 to 3 excluded. Key in the code autodf.ilock within brackets 1:3. Then hit Alt and Enter. Get the specific scalar quantity at row position 2 and column position 3. Key in the code Ford_Torino_disp equals autodf.ilock within brackets 4, 2. Ford_Torino_disp. Then hit Alt and Enter. Get the same specific scalar quantity at row position 2 and column position 3. Key in the code Ford_Torino_disp equals autodf.iat within brackets 4, 2. Ford_Torino_disp. Then hit Alt and Enter. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in 3 hashtags Boolean indexing. Then hit Alt and Enter. Compare if the column model year is in the specified list. Key in the code autodf within brackets within quotes model year dot is in within parentheses a list 81, 82. Then hit Alt and Enter. Each element in the column model year is compared to the specified list and an array of Boolean values is generated. Use the isIn method for filtering out from the DataFrame AutoDF only the rows for model years 81 and 82. Key in the code AutoDF within brackets AutoDF within brackets within quotes model year dot is in within parentheses a list 81, 82. Then hit Alt and Enter. Review the all-numeric DataFrame floatsdf. Key in the code floatsdf. Then hit Alt and Enter. Compare the DataFrame floatsdf with the number 5. Key in the code floatsdf is greater than 5. Then hit Alt and Enter. Each element of the DataFrame is compared to 5 and a 2-dimensional array of Boolean values is generated. Specify the above Boolean expression as the selection criteria between the brackets after floatsdf. Key in the code floatsdf within brackets floatsdf is greater than 5. Then hit Alt and Enter. Only those values in DataFrame floatsdf which are greater than 5 are selected. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in 3 hashtags setting. Then hit Alt and Enter. Review floatsdf. In the new cell, key in the code floatsdf. Then hit Alt and Enter. Get the number of rows in the floatsdf data frame. Key in the code len within parentheses, floatsdf.index. Then hit Alt and Enter. Create a series of date-time index for days in the year 2021. Key in the code pd.date_range within parentheses, within quotes, 2021-0101, comma, periods equals len of floatsdf.index, comma, frequency equals d. Then hit Alt and Enter. Let's assume each date refers to one data collection date for the rows in floatsdf. Create a Pandas series with these data collection dates. Key in the code dates equals pd.series within parentheses pd.date_range within parentheses, within quotes, 2021-0101, comma, periods equals len of floatsdf.index, comma, frequency equals d, dates. Then hit Alt and Enter. Set the above date series as a column in the floatsdf data frame. Key in the code floatsdf within brackets, within quotes, measured dates equals dates. Floatsdf. Then hit Alt and Enter. Set the measured dates column as the index for the data frame floatsdf. Key in the code floatsdf.set_index within parentheses, within quotes, measured dates, comma, drop equals false. Then hit Alt and Enter. Note that the default integer sequence row index has been replaced by the column measured dates. Also, note that the column measured dates has not been dropped from the data frame. However, the above cell created a new object which was not saved. Key in the code floatsdf, then hit Alt and Enter. The original floatsdf data frame is not modified. Set index to column measured dates and modify the original floatsdf data frame. Key in the code floatsdf.set_index within parentheses, within quotes, measured dates, comma, drop equals true, comma, in place equals true. Then hit Alt and Enter. Note that nothing was output by the above code, meaning no new object was created. However, the above cell modified the original floatsdf data frame. Key in the code floatsdf, then hit Alt and Enter. Note that measured dates is now the index of the data frame and no longer a column. View the index of the floatsdf data frame. Key in the code floatsdf.index. Then hit Alt and Enter. Get the first data frame row by label. Key in the code floatsdf.lock within brackets, within quotes, 2021-0101. Then hit Alt and Enter. Get the last data frame row by position. Key in the code floatsdf.ilock within brackets, -1. Then hit Alt and Enter. We could revert to the default integer row index. Key in the code floatsdf.reset_index open and close parentheses. Then hit Alt and Enter. We could revert to the default integer row index, dropping the current index column measured dates. Key in the code floatsdf.reset_index within parentheses, drop equals true. Then hit Alt and Enter. But again, we did not save the reindexed data frame objects created by the above cells. Key in the code floatsdf, then hit Alt and Enter. Our floatsdf data frame has not been modified in place internally. Generate a numpy array as long as the floatsdf data frame. Key in the code np.array within parentheses, within brackets 5 times len of floatsdf. Then hit Alt and Enter. Set a new column in the floatsdf data frame by assigning with a numpy array. Key in the code floatsdf within brackets, within quotes, stem length equals np.array within parentheses, within brackets 5 times len of floatsdf. Floatsdf. Then hit Alt and Enter. Get the first value of column stem length by label. Key in the code floatsdf.lock within brackets, within quotes, 2021-0101, comma, within quotes, stem length. Then hit Alt and Enter. Set the second value of column stem length by label. Key in the code floatsdf.lock within brackets, within quotes, 2021-0102, comma, stem length equals 6.5, floatsdf. Then hit Alt and Enter. Set the second value of column stem length by the faster at notation. Key in the code floatsdf.at within brackets, within quotes 2021-0102, comma stem length equals 6.25, floats df. Then hit Alt and Enter. Set the third value of column stem length by position. Key in the code floats df.iloc within brackets 2, 4 equals 4.5, floats df. Then hit Alt and Enter. Set the third value of column stem length by the faster IAT notation. Key in the code floats df.iat within brackets 2, 4 equals 4.75, floats df. Then hit Alt and Enter. Make all positive values negative. Key in the code floats df within brackets floats df is greater than 0 equals negative floats df, floats df. Then hit Alt and Enter. The corresponding elements were assigned negative values. Ouch! If that was a mistake, we could delete the above cell and rerun the kernel to recover our data frame. Key in the code floats df within brackets floats df is less than 0 equals negative floats df, floats df. Then hit Alt and Enter. However, we will negate the negative to make it positive. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in 2 hashtags missing data. Then hit Alt and Enter. Initialize a random number generator object with a predefined seed. Key in the code rng equals np.random.default underscore rng within parentheses seed equals 12345. Width underscore data equals np.round within parentheses rng.uniform within parentheses low equals 2.0, comma high equals 3.0, comma size equals len of floats df, comma 1. Width underscore data. Then hit Alt and Enter. Note the generated 150 width measurements. Create a Pandas series from the new set of measurements. Key in the code stem underscore width equals pd.series within parentheses width underscore data, comma index equals pd.date underscore range within parentheses within quotes 2021-0103, comma periods equals len of floats df, stem underscore width. Then hit Alt and Enter. Note that the index starts from 3rd January, missing the first 2 dates. Add the new series to the floats df data frame. Key in the code floats df within brackets within quotes stem width equals stem underscore width, floats df. Then hit Alt and Enter. Setting a new column automatically aligns the data by the indexes. The first 2 dates for column stem width are missing data, while the last 2 measurements from the added series stem underscore width were ignored. Get the Boolean mask where values are nan. Key in the code bad underscore data equals pd dot is na within parentheses floats df bad underscore data. Then hit Alt and Enter. Drop any rows that have missing data. Key in the code floats df dot drop na within parentheses how equals within quotes any. Then hit Alt and Enter. Note that we lost our first 2 date rows. Or we could fill the missing data with the default value. Key in the code floats df dot fill na within parentheses 0, comma in place equals true. Then hit Alt and Enter. This time we modified the actual data frame floats df. Check out the cleaned up data frame. Key in the code floats df. Then hit Alt and Enter. Press Escape and then M to make the new cell a Markdown cell. In the new cell, click and key in 2 hashtags operations. Then hit Alt and Enter. Press Ctrl S to save your notebook. Press Escape key to ensure that you are in command mode. Close the notebook. In the notebook dashboard, click on the Quit button. Close the browser window. Close the Anaconda PowerShell command window. Close File Explorer if open. We now understand viewing, selecting, and setting data. Let's understand miscellaneous data operations. To keep us motivated to produce more of such high-quality free content, please subscribe to this channel, hit the like button below, leave a comment or 2, and share this video with your colleagues, friends, and other budding cloud analysts. Hit the bell icon below to actively follow along with the rest of our series.